Okay. All right. So if I'm looking at differentiation, obviously this is calculus, and the reason why you're dealing with calculus is because differentiation is a way to analyze certain, let's say, equations by getting its differential. Okay, so that's like the derivative. So with this particular section, you have two things. Number one is the function, and then number two is the derivative. Okay, those are the two things that you'll be seeing in this chapter. The function and then the derivative. Alright, so the function is basically going to be something like x squared plus 2. Okay, so it'll be f of x. And then the derivative is f dashed x. That's how they denote it. Okay, so f of x is the function, and then the derivative is the f dashed x. Sometimes they also use this. So y equals, let's say, x plus 3. Okay, just as a simple one. And then the derivative could be dy over dx as the derivative. That's just the notation. Right, so notation-wise, that's what they use to denote a derivative. So a derivative is given like that or like that. Normally, you would have to find the derivative, and you would have to then use that, the function, in order to get this. Okay, so the one, okay, is used to get the other. Right, so you need the function to get the derivative. Okay, and the process that is carried out is called differentiation. Yeah, that's what it's called. Right, and that's what this basic chapter is looking at. Okay, and then obviously application wise, you need to look at two things: marginal profits and marginal cost. That's all. Alright, so what is marginal profit? Well, when you get an equation y equals ax plus b, you know that's a straight line. Okay, so a straight line will have a gradient, a slope, and it will have certain intercepts. Okay, so remember when we drew that, you've got a paper, you can write on this.
Yes.
Okay, so like this, y-axis, x-axis. Okay, it doesn't matter what the line looks like. Let's just say the line's like that. Okay, so what is that? X-intercept. What is that? Y-intercept. Okay, what's special about this line? It has an m, which is a slope. Okay, which is the gradient. So y equals mx plus c is the normal straight line equation that you would have done in maths. Or y equals here ax plus b. Okay, so the a in this equation is representing the slope, which is the m, and the b is representing the y-intercept, which is the c. Okay, of your straight line. Okay, so that's just like basic stuff that we would apply here. But remember, here we're focusing specifically on marginal profit and marginal costs. Alright, so if you're looking at a function, you'll have a cost function like that, and you'll have a revenue function like that. How do you get profits? Think about accounting. What is profit?
It's the cost minus...
The cost.
Oh, no. The profit minus the cost.
No, not the profit, the revenue.
The revenue.
Okay, so revenue minus costs would give you profit. Right, so do you agree revenue could be given by a function? Okay, a graph, a formula, and then so can costs. Cost can be given as an equation. So here in the textbook, they've given you that equation for cost, and they've given you that equation for revenue. Right, so if I wanted the revenue minus the cost, I would take 250x, which is there, and I would then subtract the cost, which is that. Right, so this minus that. Okay, then you've got an equation for what? For profits. Right, so if you look at this equation, you've got x squared here, and it's a negative x squared, so that's a parabola, right? Okay, remember we spoke about these graphs. Let me draw it here actually. Just ignore this for now. Let me just add a new slide. Okay, remember we had this. Unhappy. And then we had that. Happy. And then we had this. Okay, irrational. Right, so here we had no x intercepts. Here we had 1 2 x-intercepts. Do you agree? Yes. Here we had 1, 2 x-intercepts. Right, the only thing different with this graph is the one is sloping down and the one is sloping up.
Yeah.
Okay, so the unhappy graph is obviously going to have a min or a max.
Yeah.
It'll have a max. And this will have a min or a max.
A minimum.
It will have a min. Okay, so these points here would be the turning points. Remember that? And those points there would be the turning points. Right, so the turning point we learnt last time was x equals minus b over 2a. That's what you can use to get the turning points.
Yeah.
Okay, you can also use a derivative. Right, so how the derivative works is that if I had to draw a tangent, do you remember what a tangent is? Tangent is a line touching the curve. Straight line. That's a tangent. Straight line, that's a tangent. Okay, so any straight line that touches the curve is called a tangent. Right, so these lines that are on this side, these tangents on this side on the left, are they sloping up or down?
Down.
No, they're sloping up. Okay, because you read from left to right.
Yeah.
Right?
Okay.
So left to right means we've got from the left going to the right sloping upwards. So m here is positive. Okay, on the right here we've got m what? Positive or negative? Which way is the gradient sloping? The tangents?
Negative.
Yeah, so if we were to draw tangents, these tangents would have an m of minus.
Yes.
Alright, so if we're looking at this, you can see that m starts positive on the left, and so basically the lines are very steep, 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 and then it becomes flat. Okay, and then where is it flat? That's flat right over there on the turning points. Right, and that would be m equals 0, because that's the slope. Okay, so that's how you like make a hill. A hill is a lot of straight lines that are just going up, 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 flat, and then down, 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 down. Okay, that's what creates this thing. Alright, so if you look at that, you can see that the turning point occurs when m is 0. If m is 0, that means the slope is 0, meaning it's flat. Okay, so that would be the maximum point. Right, so you can find a minimum or max. So when finding a min slash max point, comma, we can use a derivative equal to 0. Okay, and that's what you do. Right, so a minimum or a maximum point will be achieved where the derivative is 0. Okay, so that's what you do. And why am I doing that? Because of this. Right, so this is going to be m equals 0. Okay, and because of that, f dashed x is the derivative can equal 0. And it'll find me that point. Okay, so that's just the background. That's just the theory. Right, that's kind of what they've shown you here. So have a look at the graph. Right, this graph is sloping up. So at some point in time, what's going to happen to the graph?
It's going down.
It's going to, well, positive slopes, then flat, and then negative slopes. Does that make sense?
Yes.
Okay, so this point over there would be the max. Okay. Right, and that max we can find by getting the derivative equals 0. Okay, so now we need to know how to get a derivative. Right, so this is how you do a derivative. Where's my slides? Here. Okay, so this is the rule for a derivative. If you have a function, and then remember the function is what's on the left, and you get the derivative on the right. So the function is y equals xn. Okay, the derivative, which is dy over dx, it's just the denotation for a derivative, would be the n x n minus 1. So basically what you do is you write down the exponent and then you minus 1 from it. So here's the example. Here I've given you the function y equals x squared. Okay, we know the derivative is that, but why is the derivative that? Well, this is how you do it. So what does the equation say? Write down n. So what is n here? 2. So dy over dx equals 2. Then you write down x, okay, which is the x, and then you write down n minus 1, which is 2 minus 1. Okay, so what is that? 2x. That's the derivative.
Okay.
Okay. Right, so now you would have to do the same thing with these. So what is the derivative of that? What would dy over dx be? 3, write down the n, and then x, and then what's it? 3 minus 1. So it's 3x squared.
Okay.
Does that make sense?
Yeah.
Okay.
So number 2
What would
will
that
be dy over dx.
The derivative would be
Then 5x 5 minus 1 equals 5x to 4.
yeah. So you can go from there to there. Okay, you don't have to show this working in between. Okay, so you just reduce it by 1. Okay, this one would be what?
Okay, so it would be the derivative equals a half
Yeah.
x and then a half minus 1. So it would be minus a half.
Okay, when you have minus a half, this is written like this. Okay.
Okay.
Yeah, but it actually should be at the bottom, not the top. It should be here. Okay, because negative means in the denominator. Okay. Alright, and then this one.
That would be y equals minus 1 x minus 1 plus 1.
No, minus 1 minus 1.
Oh, minus 1.
It's always minus 1, eh? Okay,
and it's
so
minus 2.
it'll be minus 1x to the minus 2. Okay, we don't write negative exponents, and we don't write 1s in front of numbers. So it'll be negative 1 over x squared. Okay. Right, the last one, just use a different color. So dy over dx is, what is that? Minus 3 x to the minus 3 minus 1.
Yes.
Which is minus 3 to the x minus 4, which is minus 3 over 4. X, ooh, hold on, where's the x? The x should be, made a mistake. Yeah, well, actually, no, it's fine.
Back.
It just needs to go there. Yeah, it's minus 3 over x to the 4. Yeah. Okay. Is that alright?
Yeah.
Okay. What happens now if you have a number in front of it? Same thing applies.
You multiply the 3 by the 5.
Exactly. So dy over dx is going to be 15x to the 3 minus 2. So that's 15x to the minus 1, right? 1, sorry.
Okay.
I don't know why I wrote a 2 there. 1. Okay, because the answer is a 2. I think that's why.
Okay.
Okay, this one.
Equals 10
T to the 4.
4. The next one is 10 multiplied by half,
Which is 5.
Y half minus 1.
Yeah, so 5y to the minus a half, which is 5 over y. Okay. Right, this one, if you have a constant, the constant just falls away. Okay, because the derivative of a constant is nothing.
Okay.
Alright, so this would be dy over dx equal to minus 5x to the minus 6.
Okay.
Okay, this one, what happens to the constant?
Okay, but then what happens there?
You can write it again if you wanted, like this.
Minus 6. Oh. Yeah.
Okay.
Okay, so the 32 falls away.
Minus 6 times minus 1.
Yes. Okay.
Okay, and that's how you do derivatives.
Okay.
Alright, then that's it. That's what you needed to know from this chapter. Okay, so derivatives can be applied to questions because we can use it to find minimums and maximums. That's what you use it for in terms of applications. So let me just put a note here. Applications. Alright, so the first application, if I have the total revenue function, okay, the derivative will be the marginal revenue. Okay, so remember I said here function derivative. Alright, so if you've been given the total revenue function, if you apply the differentiation and you get the derivative, this derivative is going to represent the marginal revenue. Okay, the same thing with this. Total cost function, the derivative of the function will be the marginal cost. Okay, that's how it works. Right, so whatever the function is, if you derive the derivative from the function, you get the marginal whatever it is. Okay. Alright, so that's what you've got here. So it can even apply to profits. Okay, so if you have the profit function, so this is the profit function, there's the profit function, there's the profit function. Okay, so if I wanted marginal profit would be the derivative, the dy over the dx. Okay, and then that would be x times 250. Well, x is to the power 1, so it'll be 250. Okay, and then I've got a x to this x squared over 1 over 10, so minus. So 2 times negative 1 over 10 is negative 1 over 5. Okay, and then I'll minus 1 there. So then x2 minus 1 is 1. So that's it. There's a derivative for that function. Okay, so now where's the derivative here? Do they show you that? Okay, there they show you the same thing as I showed you previously. That's the general equation. Okay, and then they give you these rules aren't important because as long as you know how to find the derivative, that's the most important rule. You can just apply it to different scenarios. Okay, remember I had a constant in front. Let's see. Yeah, have a look. There we go. There's the profit function, right?
Yeah.
And then there's the derivative. 250 minus x over 5. See? There's it there. Okay. Right, so it's just applying the differentiation. That's what you're doing. Alright, so we've done that, and then obviously you can find. So now once you've got the function, if I wanted marginal profit, which formula am I going to substitute these amounts in? I'm going to substitute into the f dashed x, because f dash x gives me the marginal profits. Okay, so you're using the derivative, you're not using the function. Right, so we'll see examples later on. Was that it? Yeah, and then just the marginal cost. Same thing applies here with marginal cost. Okay, marginal cost is looking at, well, if this is the cost function, okay, there's the cost function. Right, if we're looking for the derivative, it's going to be c dashed x. Okay, so c dashed x would be the derivative of this. Okay, so x squared over 10. If I times the 2 into the 1 over 10, I'm going to get 1 over 5. Okay, because how did I get that? How did I get the 1 over 5? The 1 over 5 is a 10th times 2. Okay, which is 2 over 10, which is 1 over 5. Okay, so it's that 2 times that 10. Okay, then what do? You minus 1. So x2 minus 1 is 1. Alright, so that's the derivative. Okay, where is it? There's it. There's the derivative. There's the function, there's the derivative, same thing. 1 over 5x can be written as x over 5. It doesn't matter. The notation is not so important. Okay. Is that alright? Okay.